Hi, this is Glenn Burden at the Maker Hive, and I'm going to talk about the new Pico by B3 Innovations hot end. It's smaller, more compact. I like the looks of the hot end itself. I gotta say, I'm not real crazy about all these things sticking out of the sides of it. One of the things I really like about the hot end is it's all assembled. I don't have to put it together. I'm sure a lot of you are familiar with the E3D hot ends. They come in the bag and you have to assemble them. If it's the E3D Lite, you have to torque it properly. This is all assembled. All I had to do is screw the thermistor in, and that might be just because of the options. There's different thermistors you can get. The fan out the side, I don't know, I don't see why the fan just couldn't stand this way and blow across the fins. I may do some things with that later. Right now I'm gonna use it as is and see how everything works out. The heat cartridge here, I may bend this up. I might try mounting it this way. The thermistor's nice and like this, but again, it's something sticking out, and it kind of takes away from the whole idea of being a small, compact hot end. So, like I said, I'm going to try it as is first, and then I'll make some modifications, play with the cooling, fin cooling a little bit with some other ideas that I have, and we'll see how that goes. Because if you really look at it, by the time, even if I bend this up and the fan's sticking out the side, by the time I get this all hooked up, it's really not a whole lot smaller than your normal hot end. One other thing that I found that I'm not real crazy about is the space here isn't the same as the E3D, which there really isn't any standards in the DIY 3D printing community. I'll talk about that in a minute, but one thing that I'm a little disappointed was I want to use my hot end plug-in board, and I can fit it like this and use it just like that. I really wanted to use my aluminum clamp from 713 Maker. You can find them at 713maker.com. But it clamps like this. Well, should. But because that's not the same depth, I can't get the board and the aluminum clamp. Like that to hold everything together. But so it's not that big of a deal. I can just not use that piece and clamp this in here. But as I mentioned earlier, there's no standards in the DIY community, and I think there should be. Just as a side note, if you agree and think that it would be beneficial to establish a set of standards, so like with computers, you have an ATX motherboard, and it'll mount, has the same footprint, and it'll mount in any ATX case. So I kind of feel that any hot end should be able to mount on any 3D printer, and they could if the mount part of it was the same standard, the same spacing, same diameter. And anyways, if you think that's a neat idea, or you'd like to be involved, or just want to tell me, hey, it's a good idea, go for it, shoot me an email and we can discuss it. I'm going to try and get some people involved and some manufacturers involved. But anyways, back to the Pico. I'll figure something out here to use this. I'll get it The other issue I have is this guy. This is a voltage regulator that takes the 12 volt and 5 volts out, because the fan is a 5 volt fan. Now most 3D printers have 12 volts only running to the hot end, and that same 12 volt is common between all the fans and everything. So you can't really put this somewhere else. You pretty much have to put it between the fan and the rest of the electronics on your hot end, or run a separate wire to it. If you got, separate wire running to it to your hot end, that's great. Otherwise, if you're using something like this, it uses the hot end positive as common between all your fans, your LED, and everything on here. So you'd have to put it between your output here and the fan. So what I'm going to do, well, one idea I had to do is take a pin header. It'll fit in there, and then you can tighten the screws down onto the pin header, and then I can solder it in place of my fan right there. You want the screws facing out. If you do this, you want the screws facing out. This is positive, and that's the positive side of the fan connection. That'll give you your 12 volts in. Then I'll bring the fan wires up and just wire them in on this side here. And that'll give me 5 volts. But I don't like this big thing. So another thing I may do is use a resistor and create a voltage divider. Drop 7 volts across my resistor, and that'll give me 5 volts on the fan. For this to work, we need to know the resistance of the fan, and you can't just measure the ohms across the 2 wires of the fan, because it's a coil and that's going to vary depending on the voltage applied to it. So you need to hook it up to the operating voltage, which is 5 volts, and then we'll hook a amp meter here in line to read the amp draw of the fan. And mine is giving me 0.052 or 52 milliamps. Now we can use Ohm's law. So it's 5 volts divided by 0.052 gives us right about 96 ohms. Now theoretically, if I put a 96 ohm resistor in line with the 96 ohm fan, I'm going to have a 6 volt drop across each with a 12 volt supply. So in order to get this down to the 5 volts threshold of the fan, I want to increase this resistance a little bit, and mine worked out to about 120 ohms, which gives me roughly a 5.2 volt drop on the fan. Now the fan's drawing 52 milliamps, so, and it's drawing that through the resistor, and there's a approximately 7 volt drop across the resistor. So we need to take the amperage drawn through the resistor, multiply that by 7 volts, and that gives us about 364 watts. So that means you'll need a resistor of at least a half a watt. So I'm going to order me some 120 ohm half watt. I might go ahead and get some 1 watt also, just in case this one still gets a little warm warm than I like it. And I may give that a shot, but until then I'll go ahead and use the voltage regulator and see how that one works out. Okay, I have my B3 Pico all mounted to my quick change hot end plate, and as you can see I went ahead and used the regulator that comes with it, but I will be changing it to a resistor like I discussed, mainly because if I try to print too big, when this tube moving around, it's going to catch that tower sticking out of there. Like I said, if you got separate wires running to it, you can probably have this up by your printer controller board instead of on the plate here, but this uses the hot end positive to power everything on here, so I have to have it right here where the fan's at unless I want to run new wires. But I'm going to try it like this, see what happens. I'll print small so the Bowden tube don't hit this. Okay, issue 2 that I see is, since I'm using a Bowden tube, I need to use this collet, which is kind of flattened and cracked, but I'm going to try and use it anyways. I think it'll be alright. I can get the collet down in there. Okay. Try and get it to snap into place, but the problem is going to be snugging the Bowden tube. Well, I was wrong. As you can see, it's split in half, so I'll have to wait till I get a replacement. And one other suggestion, if you continue with this block, make these connections a spring cage connection. It's a lot better for vibration. They don't come loose. Screw terminals can work loose, and tiny wires like this just do not clamp good in those. If the connector was in there, you know, and when I push this in, you got to be able to raise that clip up while holding this in tight, because if you can't do that, it'll slide back and forth like this just a little bit. To show you what I'm talking about here, once you put the Bowden tube into that clip, you still have a little bit of play there. You want to be able to pull this up while pushing this in, and that takes the play of the slop in and out. With that clip being way down in there, it's going to be almost impossible to do that. So this is an E3D hot end that has the same Bowden clip, and it's, as you can see, it's lifted up, and there's no play in that Bowden tube whatsoever. Okay, I went ahead and removed the coupler on the from the E3D hot end to use on here, since the other one broke. Even if I take my hot end back off to give me a little bit more room, this is a nightmare to try and get down into that hole, so hopefully the final design has this already installed. But I'm going to try and get this in there. I'll get the hot end mounted and hopefully get it squirting plastic today. Here's a tip on how to cut your Bowden tube end off square. The part that goes down into the hot end you want cut square as possible so it don't leak. What you can do is take something you know is square, put it on your bench, let the tube come past the end just a little bit, then lay your blade against the square block and push down, and you should get a pretty square cut. In conclusion here, overall I like the design, I like the smallness, the compactness of it. I can see what's going on in there a little better around the hot end. I would like to get rid of this fan sticking out the side and possibly the thermistor sticking out there. That would clean it up even more. So I'm gonna do a few prints with it, see how it prints out. I think it's gonna print fine. And then I'm going to do some modifications to it and see if I can improve it a little bit. Okay, the print's all done. I'm getting a lot of back pressure out of the nozzle. When you get a lot of string coming out afterwards, and you've had a lot of back pressure. Could be the thermistor's not quite adjusted right, and the temperature's a little bit off. I was printing at 230 though at PLA. My meter checked in at about 210, which should have still been plenty hot enough. So I'm not sure why I'm getting that much back pressure. As far as comparison, the one on the right is done with E3D, and the one on the left is done with the B3 Innovations Pico. I suspect the quality of print would be pretty reasonable with any of the other ones, but I do like the small compactness. If we can get it compacted even a bit more, that's great.